Hi, this is Adam Griffin with the second video for this week, and we're going to be doing number problem 3, which is a truck with mass m equals 15,000 kilograms traveling south at 20 meters per second collides with a car with mass lowercase m of 2,000 kilograms traveling west at 30 meters per second. So once they collide, the car and the truck stick together and move as a single unit after the collision. What will the velocity and direction of the car and the truck be after the collision? So to solve this, we can figure out the momentum of both and their directions, and we can turn that into two different vectors based on their momentum. So to solve for momentum, we have our momentum equation, which is P equals mass times velocity. So to find both of those, so we have a little diagram right here. So we have our truck, which is moving south at 20 meters per second, our car, which is moving east at 30 meters per second, and then we find the momentum for both. So our momentum in the y direction is 300,000 kilograms times meters per second, and our momentum in the x direction is 60,000 kilograms times meters per second. So this is our final vector, which is going to show us the final momentum. So not the velocity, only the momentum of the two. And we solve for this just like we would any other vector. And we find the length of this with the Pythagorean theorem. So we get that it comes out to 305,941 kilograms times meters per second, which I rounded to 306,000 because I don't want to say it every time. And then you divide that by the two masses because they act as a single unit. So once they have collided, you have a single unit with both of the momenta, I believe is plural, I'm not sure. But anyways, they're acting as a single object with mass m plus m, and its momentum and direction is equal to just how we would do any other vector. So we'll do that over here. So we get that if we divide the momentum of this, so we found the magnitude of this vector, right? We divide it by the mass to get our velocity. So that comes out to 18 meters per second, which is how fast they're moving after they collide. And to figure out the direction that they're moving, we just have to figure out this angle or this angle, doesn't matter. So we get that theta equals inverse tangent of our momentum in the x direction, or pardon, our momentum in the y direction divided by our momentum in the x direction, which gives us 1.37 radians. So that's this angle, which, and this direction would be east. We can convert that into degrees, and we would get that the direction after they have collided is 79 degrees clockwise from east. And that is really all there is to it. Just make sure if you had this problem, or I guess you would have already done it, that you're not just stating the momentum and that you divide by the masses together to get their velocity. So that is how you do problem 3. I hope this was clear, and thank you.